It says it's in quadrant 1, and in quadrant 1, everything is positive because it's all students take calculus. So in quadrant 1, everything is positive, so you should have been able to go C or D. So those people that had A and B kind of didn't even realize that quadrant 1, they're all positive. So you have to study that. You have to know which quadrant is positive and negative. It seemed like everyone that knew how to get it as positive or negative got it right because everyone else had C. I'm going to go ahead and take a picture of my work. All right, so I knew that cosine squared plus sine squared equals 1. So my cosine was 3 over 5, so it's 3 over 5 squared plus sine squared equals 1. 3 over 5 squared is 9 over 25 squared plus sine squared. Just change that 1 to 25 over 25 because I knew I had to have a common denominator. I subtracted 9 over 25 from both sides. I got sine squared equals 16 over 15. Took the square root of both sides. I knew it had to be positive because quadrant 1 is both positive. Once again, if you did not know that, you need to study that all students take calculus. Otherwise, you're going to struggle on these problems on the test. I guarantee they're on the test. And our test is next Tuesday. Next Tuesday is our test. All right, questions on this? All right, questions on the homework. Yeah, Jack. Put mine. Hey, just a second ago. So 93 and 94, those are the last two. Jack, are those the last two?
Yeah.
Can I see yours real quick? Take a picture of it. I had my... Oh, no, never mind. I have it here. All right. 93 and 94?
Yep.
All right. They're no different than 89 and 91. They're the exact same problems. So on the belt work we just had, it says quadrant 1, which tells me both are positive, so my answer is going to be positive. For 93 and 94, they actually made your life easier. They said cosine alpha is bigger than 0. So I put on here, the only reason why they put that is now you know that cosine is positive. You don't have to worry about looking at quadrants. It just says right off the bat, your answer needs to be positive. So this cosine alpha is greater than 0 just tells you that cosine's positive. So I knew my answer needed to be positive, but then we just go to sine squared plus cosine squared equals 1, and we solve it the exact same way. Does that make more sense? Leslie?
Thanks.
Other questions? Hey guys, just so you know, on my answer key, I didn't put work for this one or this one. If I'm looking over your homework and you have these completely done and just an answer or nothing in these two, I'm going to assume that you just were copying the answer guide and you didn't actually understand how to do it and you just left those blank and you didn't even try them. So you lose points on that every time. So if I leave something blank and you leave it blank also, in my mind, I'm looking at it like you're just copying my answer guide and that blank wasn't filled in, so you didn't do it. There's no way you knew how to do these two and didn't know how to do these two because they're piggyback off each other. If you had questions on how I did this, then yeah, this one could be blank too. They both could have little bits of work that don't make sense. But never should I see the exact blanks I have on the answer key are also blanks in your homework because your homework is still, you have to try the problem. Whether you know how to do it 100% or not, you still have to attempt it. And if you get the wrong answer, leave your work down, because if it's blank, I'm going to assume you didn't do it, and then you lose points. All right, questions on that? That make sense? All right. Other questions on the homework, though? Because there were some blank on other people's. Okay, know how to do these. I guarantee they're on the test. All right, today we're going to talk about graphing sine and cosine functions. And the graphs of sine and cosine functions are curves. They're curves, and it's because the values go around a circle. We're basically going to take these points and put them on an x, y-axis instead of a circle. We're going to put the values going across our x values when things are a certain degree. So what we're going to do is we're just going to pick points and we're going to plot them. Kind of like if I gave you x squared equals y, you just plot x equals 0, x equals 1, x equals 2, and you plot those points and you see what shape that makes. That's exactly what we're going to do. But we're going to pick angles instead of specific things. We're going to pick things like, we're going to find the value of sine of 0. So you're going to go around and just pick key points. We're going to pick the sine of pi over 2. We're going to do the sine of pi. We're going to do the sine of 3 pi over 2. And finally, we're going to do the sine of 2 pi. So what we're doing is we're graphing a full revolution of the sine. We're graphing a full revolution from 0 to 2 pi, inputting specific key points. Well, who can tell me what the sine of 0 is? What is the sine of 0? Liv? 0. What's the sine of pi over 2? Some besides Liv. Yeah, 1. And then the sine of pi is actually 0. The sine of 3 pi over 2 is negative 1. And finally, the sine of 2 pi is 0. These are all unit circle values that you need to know. You shouldn't have to plug these in your calculator. You should just know these. These are key sine points. That's right here, way up there, right here, and we went back here. All right, to plot these points, we need to have our x-axis labeled. So we're going to use radians to always label our x-axis. So this is the point 0, 0. Then we did pi over 2, so we'll put pi over 2 here. Then we're going to have pi, 3 pi over 2, and finally 2 pi. Now, if we plot these points, I'm going to plot 0, 0. And where pi over 2 is, I'm going to go all the way up to 1. The sine of pi is 0. The sine of 3 pi over 2 is negative 1. And finally, the sine of 2 pi is right there. Never, ever connect these with straight lines. Because if you plot these points in between, like if you plot sine of pi over 6, then sine of pi over 4, then sine of pi over 3, you're going to see this is going to make a really nice curve. It's going to look something like that. Not my best drawing, but it'll do. The first thing I want to put, you know when you graph, you pick a few points for x squared, how it goes on forever in both directions? The same thing's going to happen for sine and cosine. You are allowed to keep going around that circle as many times as you want. I could find the sine of 4 pi, 5 pi, 11 pi. This graph just keeps going on and on forever. So it actually goes like that and would come down like this and go up like that. It goes on and on forever, up and down, up and down, up and down. But the good thing is, whenever I ask you to graph, I'm always asking you to graph. This is called one cycle. One cycle is from where it starts to where it would repeat again. We just need to see that one cycle in order to be a solid graph. All right, some key terminology. The sinusoidal axis is a line that runs along the middle of the graph. So our sinusoidal axis here is actually our x-axis. It is not always your x-axis. Sometimes you shift this up or down, but the sinusoidal axis is the one that runs smack dab between, where you have the same amount up and the same amount down. The next thing we're talking about is amplitude. That's the distance between the sinusoidal axis and the max or min. So our amplitude is this distance here. It's basically half your total height. From tallest point to bottom point, you half that, and you have your amplitude. Your amplitude is always positive. Your amplitude is always positive. So this is my amplitude. And the amplitude in this case is going to be what? It is 1 unit from our bottom to our top. Our amplitude is 1, and our amplitude is always positive. It's a distance. It's a distance, so it's always positive. The next thing is a period. That's the length to complete one full cycle. That is the solid lines right here. That is one cycle. So your period is from when you start to when it's going to repeat. That's the period. And in this case, it is 2 pi. Now, when you're doing like your homework and stuff, you're going to put all that facts off to the side. So our amplitude is 1. Remember, that is always positive. The period, in this case, is 2 pi. That is also called one cycle. If I asked you to draw 2 cycles, you would have to continue and draw it one more time. And that can be a possibility where I say draw 2 cycles of something. And that's the graph of a sine function. Now, if you can graph a sine function, you can graph a cosine function because it looks almost identical to this graph. So let's go ahead and do the cosine function the same way we did the sine function by graphing points. So we're going to do the cosine of 0. We're going to do the cosine of pi over 2. We're going to do the cosine of pi. We're going to do the cosine of 3 pi over 2. And finally, we're going to do the cosine of 2 pi. I want you to find those values and graph that graph. Graph that graph. It's a horrible sentence. So find each of those values and make the graph. That is perfect. It looks a little different, but if you look at coming the other direction, it's the exact same up, down. It's the reason why we graph that cycle, so that you can tell which one's your cosine and which one's your sine. Equals 1. Well, if I knew the sine value was 0, the other one had to be 1. They're in pairs of 0, 1, or 0, negative 1. So if one's 0, the other one's either 1 or negative 1. Well, cosine of pi over 2 is 0. Cosine of pi is negative 1. Cosine of 3 pi over 2 is 0. And cosine of 2 pi is back to 1. So plotting this, I should have the x-axis as being pi over 2, pi, 3 pi over 2, and finally 2 pi. I'm at pi over 2 is 0. At pi it's negative 1. Back up here. Back up here. It's going to look something like that. But don't forget, that looks almost identical to the sine graph. Because if I was to continue this on, it would look something like that. Then going the other way, it would look kind of like that. So they're just curves that go up and down. Your job is to remember which one starts where, because they look very close to each other. If you know this general shape, and you know cosine starts at 1, Sine starts at 0, 0. These graphs are pretty easy. You don't have to plot these points every single time. All you need to know is goes up, down, up, ends at 2 pi. Cosine starts up, comes down, comes up, ends at 2 pi. And we're going to use these basic shapes in order to transform them, but you need to know these basic shapes. All right, real quick, let's talk about the amplitude and the period. Well, the amplitude is from the sinusoidal axis. So the amplitude in this case is also 1. And the period is 2 pi. All right, so our amplitude is 1, always positive. The period is 2 pi, which is also called 1 cycle. All right, those are the primary graphs we're going to use today and tomorrow and the next day and basically the rest of the week. So the quicker you know these, the easier life is. Because this is basically the rest of the week, which means what we're doing now is the last thing we're going to learn for the test. It is graphing these and being able to transform them. But once again, if you have no idea what a unit circle is or how to read it, and you don't know what happened here, you're going to really struggle on this part. All right, you have to know these graphs, and the quicker, the better. So make sure you focus on the homework tonight. All right, real quick. These right here, these are the full graphs, the way it would bounce up and down forever. All we drew was something called the fundamental cycle. This right here, because yours isn't colored, that's your fundamental cycle from 0 to 2 pi. Same thing with cosine. This is called the fundamental cycle. Because realistically, if I say draw 1 cycle of the cosine graph, and you graphed way over here, you're correct, that's 1 cycle. But for the sake of this class, anytime I say draw 1 cycle, I'm talking about the fundamental cycle, the one from 0 to 2 pi. All right, so we don't have the graph over here. But these are our general graphs of what they look like. All right. When you're graphing these, they generally take the form of A times sine of B of X minus C. In fact, what I actually put in here is I put a little bracket to let myself know that you're taking the sine of all of that, where each letter does something specific, and the exact same thing works for cosine. I can replace sine with cosine. It's not going to be in this chapter. When we get to tangent, you're going to be able to do the same thing with tangent. All of these values with transformations work for all sine functions. In fact, it works for any function anywhere, as long as you set it up correctly. All right, the first thing we're going to talk about is this A value. That A value, the only thing it does is change the amplitude, how high and how low your graph does. What it also does, if it's negative, it's going to flip it. It's going to flip it. So rather than going up, it will go down. So once again, A changes your amplitude and can also flip your graph. So A controls up and down. A controls up and down, the stretch of the graph. So in this example, we have 3 times sine of x. Since it's right in front of sine, that's going to affect the amplitude. That's our A value. It's going to affect our amplitude. So if you looked at the graphs before, the amplitude was 1. It went up to 1, and it bounced down to -1. Our new amplitude is going to be whatever number this is. So your amplitude is going to be 3. Period, still going to be 2 pi. It's always going to be 2 pi until tomorrow. Tomorrow we'll talk about which one of these letters adjusts your period. So anytime I ask for the period today, just put 2 pi. We don't know how to change it right now. It's always going to be 2 pi. As soon as you know your period, mark your x-axis. Starting to get in the habit of that. So as soon as I know my period, I'm going to count out 1, 2, 3, 4 and put 2 pi there because I need to come out to 2 pi because I have to draw 1 cycle, which is the length of your period. All right. We'll talk about a shortcut to this. There's a way to just take half multiply by 3, but since it's 2 pi, we just know the values from our unit circle. So that's going to be pi over 2, pi, and 3 pi over 2. For every one of these today, you will mark your x-axis just like that. So in fact, I can go to the next one. Since we didn't learn how to change the period, I'm just going to mark this as pi over 2, pi, 3 pi over 2, 2 pi. So you should always have today your x-axis correct, because every one of your graphs is going to look like that. All right, the amplitude is now 3. So what I'm going to do is I'm going to draw the original sine graph. Our original sine graph bounces between 1 and -1. So it starts here, goes up to 1, goes here, comes down. This is from the front side. It just goes up to 1, comes down to 0, bounces to -1. So this right here is just the normal sine x. No change. My new amplitude is 3. So rather than going up to 1, we're going to go all the way up to 3. Our amplitude is now 3, so that distance needs to be 3. So our new one, maybe I'll pick a new color, is going to still start at 0, 0, but now it's going to go up to 3. It's going to come back down to 0, but now it's going to go to, well, -3. So that means I need to mark my negative y values. And then it goes back up to 0. So your amplitude is never going to affect those values that are actually at 0. They're just going to stretch your highest point and your lowest point. It is like it grabs it and pulls it. So that top blue one is your 3 sine x. All right, next one. It's -2 out front. It changes our amplitude, and it's going to also flip it. Well, here's the thing about the -2 and mistake that people make. Amplitude has to be positive. So even though there's a -2 out front, your amplitude is still a positive, let me put that back in black, a positive 2. Get that straight. Your amplitude is always positive, whether it's negative up front or not. That negative just tells you to flip it. That's all that negative does, is it tells you to flip it, but it does not change the amplitude. It's still a positive 2. The period is still 2 pi, because we don't even know how to change it yet, so it must be 2 pi. Let's go ahead and mark our y, 1, 2, 3, -1, -2, -3. All right, what I always do is I graph a regular cosine function first. So a regular cosine function is 0, 1, pi over 2, 0. Then it goes down to -1 to 0. And if you don't believe me, look at the other side, because we did graph this. This is our fundamental cycle of our cosine. That is no changes done. So that right there is just regular old cosine x. Pay attention to what I'm doing here. Let's pretend this is just a positive 2 right now. If this was just positive 2, instead of starting at 1, I'd start at positive 2, so my amplitude would be 2. However, because it's a negative, it flips this point down here. So rather than starting in the positive, we are now going to start in the negative. So we're going to start at -2. Our zeros don't change. That's always nice. Your zeros are always going to remain the same before you change your amplitude. Then we go up to 2. Then we go back to 0. And we go back to -2. So that is our -2 cosine x. But if you check, your amplitude is still 2. Maybe I should do that in a different color. But our amplitude is 2. And it's flipped. Questions on your A values? Changing your amplitude should be one of the easiest things you do, because we get a lot more complicated than this. So changing your amplitude is a lot of times what the first step you do when we're doing a whole bunch of stuff is just figure out what it's stretched and if it's flipped, and then you do everything else after. All right, the only other letter we're going to tackle today is our C values. I don't have the slide there, but C shifts the graph right if it's x minus C, and it shifts left if it's x plus C. So it kind of goes the wrong direction that you would think it would. So a negative C makes it go in the positive direction, right. A positive C makes it go left. So it goes the opposite kind of direction you think it would. So as example, why did we do those? Oh, there we go. All right, so we have sine of x plus pi over 2. Plus tells you it moving left. This is going to move left. So a positive, or plus pi over 2 moves it left. The amplitude is whatever number's out here. That's 1. So whatever, there's actually a 1 there, so it's 1. The period, we don't know how to change that, so that's still going to be 2 pi. In fact, I already labeled it for you. If my amplitude is 1, I'm just bouncing between 1 and negative 1, so I can just go ahead and label that 1 and this negative 1. I'm trying to think if I move that down a little bit. I sure did. I'm going to change that real quick because that's going to go really high. I actually made that 1, so I actually put tick marks in between. Otherwise, you have these really high mountains. All right, regular sine curve. Regular sine curve looks like this. It's at 0. It goes up to 1. It comes down to 0, goes to negative 1, and it bounces back up there. That's terrible. I should actually dash that because that's not my official graph. So this is the regular sine x. Now I need to shift all of those points left pi over, pi over 2 units. My advice to you is always start at the 0, 1 and see how many tick marks you move it. So we're going to move this over 1 tick mark. So I'm just going to shift that over 1 tick mark, and I'm going to do that to every one of the points. So that's going to go over 1. That one's going to go over 1. This one's going over 1. This one's getting shifted over 1. This one's getting shifted over 1. And that right there is my sine of x plus pi over 2. It's just shifted left. Every point is shifted left. Shifting left and right, is it that hard? Is it that hard to picture shifting left and right? No, it's not that hard. The only time it gets a little more difficult in that next one. In that next one. Because if you look at that next one, that next problem is, I'm looking because people are still writing, is moving pi over 6 units. We don't have pi over 6 units labeled on here. So sometimes you have to go a little deeper and label with more points. And I'll show you what I mean in a second. Is everyone done with this graph? Please don't be like, I don't want to make them slow down. All right. All right, first of all, let's tackle the period, because we know it's 2 pi. Because I haven't taught you how to change that yet, or what letter changed that. Amplitude is whatever's in front of sine. Well, in this case, it's 1 again. So I didn't change my amplitude. And now we're going to shift right pi over 6. I know it's negative pi over 6, but we're shifting right pi over 6. One way to remember it is just goes opposite. Left and right go opposite what you think. The other way is, and this is really why it works, what value do you plug in to make this 0? And that's a positive pi over 6. So what value do you plug in to make? And that's a positive pi over 6. That's why it goes the opposite direction, because you're actually looking at your x value, not this one. How you want to remember it, a negative in there is going to shift it right. Right. All right, let's do a regular old sine graph, because that's what I'll do with any one of these transformations. I'll first draw the regular one, and then what happened to it. So sine bounces between 1 and negative 1. It starts at 0, 0, and bounces between the two. But it says it's got to get shifted pi over 6 units. Pi over 6 units. Pi over 6 units isn't on here. Now you can take your calculator and figure out where pi over 6 is on here. You can kind of estimate it. But a much smarter way to do that is go ahead and look at your unit circle. If you look at your unit circle, between 0 and pi over 2 are 3 key points. Pi over 6, pi over 4, and pi over 3. So what I do if I'm going to shift something smaller than moving like pi over 2 or something is I'm going to label those 3 key points in between. So I'll just do 3 tick marks. Where according to the unit circle is pi over 6, pi over 4 happens next, and finally pi over 3 happens there. Now just for the sake of notes, we're not shifting left, but if I had to shift it left, I would do the same things. I would do 3 tick marks, but this would be negative pi over 6 in this order, negative pi over 4, and finally the last one would be negative pi over 3. Most of the time when I'm shifting left or right, it will either be one of these major points or it'll be one of these 3. I'll say shift it pi over 4 units, shift it pi over 3 units. All right, you just got to throw those 3 little tick marks in there, figure out which one you're using, and make that tick mark on the other ones, and I'll show you what I mean. So I'm shifting right pi over 6 units. So what I'm thinking about is I'm just shifting it. See, it's one of those tick marks. That means I'm going to shift every one of these just that little bit. So I'm going to make that 1 mark on each of these major points. I'm going to go 1 tick mark over. Because each of those are pi over 6 units away from your major points. Because if I'm shifting this one this far, I'm going to shift that one that far. I'm going to shift this one that far. I'm going to shift this point that far. I'm going to shift that point that far. It's always going to be the same distance. So we're just going to shift this one a little bit. Ooh, let's go back green. We're going to shift this one just a little bit. We're going to shift this one just that little bit. This one gets shifted just that little bit. And then we connect our dots. And we now have sine of x minus pi over 6. All right, so all we did today is we came up with the fundamental cycle of sine and cosine. We talked about amplitude, the period, and then we talked about how to change just 2 letters. Just 2 letters. You can change your A value, which stretches your graph. So A value stretches your graph. It changes your amplitude. And it can also flip it. If it's inside the parentheses, if it's the C value, we haven't talked about the B. We haven't talked about the D. We'll talk about those tomorrow. Not yesterday. We only talked about A and C. A is amplitude. C is left, right. And it goes the opposite way of what is showing. So if it's negative C, it goes right. If it's positive C, it goes left. I'm facing the wrong direction. I'm saying that. Lift.
What if you don't have a plus or minus? Is it just there's no phase change?
Oh, if it just is X?
Yeah.
Yeah. So in this case, there's no left or right.
Okay, so we're just right now phase change.
Yep. Okay. So I know I put on there a phase shift, and it will ask for phase shift. I kind of switched the terminology later on where I ask, are there any shifts? Because then we'll start talking about up, down. Phase shift is technically a word just for left, right, but it's not used a ton. Usually you just go, it shifted left, shifted right. It gets very awkward to go, the phase shift was left, and the phase shift, and it's just like, well, you already said left. I know what we're doing. So in the homework, it will say phase shift. But I think in the homework tomorrow, it's just going to say which way does it shift, because you're going to have to say up, down, left, right, all together. In the homework, it will say what is the phase shift. That just means left, right. I'm trying to see if there's something I needed to go over. There is nothing else I need to go over. All right, everything else is completely doable. As always, check your answers. I feel like some of us are falling in the trap already of us just hurrying up and copying answers. We do have a test next Tuesday, and if you get full points on all your homeworks and you fail your test, you fail the class. And one of the first things I do if you fail a test is I go over your homeworks. And if it looks like you just copied my stuff down, I can always say, well, you can't retake it then. All right, make sure you're doing your work.